Okay, so we're going to be working with rational exponents and radicals. Okay, in dealing with rational exponents, a rational exponent looks something like this. In other words, it has a fraction as an exponent, is what we're talking about when we're working with rational exponents. Okay? Or x to the 3/5, or okay? Those are all called rational exponents because they are rational numbers, but they are fractions. Okay? How can I convert that into a radical? So to convert to a radical, the following happens. If I have like x to the 1/2, the 1 or the numerator goes inside the radical, and the 2 becomes the index on the radical. Meaning, if I have x to the 1/2, to convert this to a radical, have my radical sign, I have an x. Okay, we said the 1 stays inside the radical, which means that I still have a power of 1 on this x. And the 2, or the denominator, becomes the index. Well, the index is the little number that goes in this v part of the radical, which ultimately means I'm finding the square root of x. Right? We see it written this way a lot more than you see it written this way. But there's reasons for writing it one or the other, because if I have a series of radicals that are multiplied together, sometimes it's easier to work with them as fractions and add the fractions than it is to multiply radicals. So if I had x to the 3/5, and I wanted to write that as a radical, put in my radical, the x would have what exponent with it?
3.
A 3. And where would the 5 go? Outside here, which means that I'm actually finding the 5th root of x cubed, which means that I'd have to take and cube x, then find the 5th root of it. Which on some of your calculators that's possible, on some it's not. What happens if I have x to the 4/7? Okay, so the 7 goes inside of here for the index, and x to the 4th.
So, the x to the 4/7, so that, do you find the square root of that 7 times, or?
No.
What is it?
Means what number times itself 7 times would give you what x to the 4th is. Okay?
Okay.
Sort of like this. If I said 8 to the 1/3, if I'm dealing with a number, most of you would probably freak out if I said 8 to the 1/3. But you have worked with this before. If I said 8 to the 1/3, I could rewrite that as 8 to the 1st with an index of 3, which means, what's the cube root of 8?
2.
In other words, what times itself gives me 8? Wouldn't it be a 2?
So if there's a 2 in there, it's basically just normal.
So this is simplified to 2.
And then the 2 in the index.
Can we do that again?
Yeah.
This one?
Yeah.
8 to the 1/3.
Okay.
If I wrote it as a radical, the 1 stays with the 8,
Yeah.
and the cube comes outside of here with an index of 3, right? Which means this is asking you the cube root of 8, which means what number times itself 3 times would give you 8? 2 times 2 gives you 4, doesn't it? Times 2 is 8,
Okay.
right?
See, what number times 3?
No, what number times itself gives you 8,
I don't think that equals 8. Okay, now I understand.
right? Well, if you had the square root of 4, don't we ask ourselves what number times itself gives you 4? Right? Which is 2 times 2. If I had the square root of 16, what number times itself gives you 16? 4. Same way if I wrote this, what number times itself gives you 25? 5. Right? Only instead of having an index of 2, this one has an index of 3. Which means what number times itself 3 times gives you 8, which would be 2 times 2 times 2.
So then you just leave it at 2 then?
Yes,
Okay.
if you completely simplified it.
Cool.
Okay? So if I wrote 125 to the 1/3 power, and I needed to simplify that, to me that's going to be difficult, isn't it? Like that, written that way. But if I wrote it as a radical, and I wrote the cube root of 125, that means what number times itself 3 times would give me 125? And you're saying that it would be 5, right?
I never would have either.
Isn't it easier to work with it this way than it is this way for that particular problem?
Yep.
And they're both the same,
I think that's about 75.
okay? What if, though, if I wrote 125 to the 2/3? Well, I could rewrite that as the cube root of 125 to the 2nd power. Or I can take this 2nd power, instead of putting it inside the radical, I could actually write it as 125, the cube root of it, squared. Which would ultimately mean find the cube root of 125, which is,
5.
and square it,
I like that one better.
which gives you 25. Okay? We okay with that? How did I get what?
125.
125.
What
What times itself 3 times? Okay? We okay? Okay. How can I go from a radical to a rational? In other words, how can I go from to having a fractional exponent? Well, we do just the reverse of what we did before. Didn't the index come from the denominator? And this became the numerator? So I do the same thing here. This is going to be my numerator. This is going to be the denominator. So I would have 4 to the 2/3 power. Okay? So if I had the 5th root of 5 to the 4th, and I wanted to write that as a rational exponent, the 4 would become what? Numerator. This 5 would become, so I would have 5 to the 4/5. Okay? We good with that? Okay. Hang on here just a second.